Okay, we're going to take a look at the investigator question. So the setup here is that we have 500 centimeters of ribbon, and that they're going to use that 500 centimeters of ribbon to basically make a display that is rectangular in shape. So we know, and the question is, investigate the state of the relationship between the length of the size and the possible area. So we've got length versus area. So basically, we have length, area. We're also going to have width, obviously, for this. And so then we're going to talk about, what we're going to, how we're going to start this. You always start an investigation with a table of values. So let's just say we know that I can't do 250. I can't do a length of 250 because if I do a length of 250, then the widths are going to be 0 because I don't have enough ribbon to do that. So basically, I have an area at 250. I have an area of 0. That's not going to work. So that's not really viable. But I could do a length of, say, 240. Now that means that I'm going to have a width of 10. A width of 10, if I put this as my width. And then I'm going to have basically my area, which is 24. Right? So, I mean, that's basically what ends up happening. And then I work my way down, 230, 220, and work out my areas and so on that way. So what happens is you work your way around and you do some investigation, but you can't just do this with 3 or 4 points. You have to do several points. And what you end up seeing is that the area ends up getting increasing, and then at a certain point it starts to decrease again. So 240, 230, 220, 210, 200, and then if you play around with the points long enough, you should start to see something happening. As the lengths are decreasing, the widths increase, right? To try to maintain that balance of that 500. And then you start to get to a point where this is the key thing to see, is that when the length and the width are exactly the same, I've maxed out my area. That's the maximum area. And if I plot these points and the length, if you will, against the area, then I start to get the shape of a parabola. You should see that. And the thing is that if I keep going here, right? So I start at 250, I get 0. And then what happens is this graph is going up, 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 and then back down. It maxes out. And then as you get smaller and smaller here along your side, your length, or whatever it is, your width is going to get bigger and your area is going to get smaller again. Okay, so we've got a parabola. We've got a parabola. We've got some points. We then need to find the equation for that parabola. But if you've got a number of points, we know that if this is a parabolic situation or a function, that I can throw those points in and I can use my calculator to find the equation. Or the other thing is that you can do is you realize that you've got x, which is one side, and 250 minus x is the other side. And then you can just use that as your length times your width kind of thing for your area. Most people don't do that. You can find it from your calculator. And then you describe fully the effects the increasing the length of the rectangle has on the area of the rectangular space. So the length increases from 0 to 125 centimeters. The area increases and it maxes out at 15,625. And then after that, it starts to, at max length and width are the same. That's another thing that you need to talk about. Length 0 and 250 centimeters gives 0 area, symmetrical about the length of 125 and so on. So you just talk about the features And if you've drawn a graph, you know that the line of symmetry is at x is 125. You know that 0, 0 is a point on the x-axis, you know 125, and 0 is a point, and so on. You just talk about the features. And this next question we'll talk about a little bit in class.